Okay, in this video I'm going to be showcasing a full wave rectifier circuit. So a full wave rectifier converts AC power to DC, and in this demonstration the converted DC power is used to turn on an LED. So before going to the demonstration, I'm going to walk through the circuit diagram and briefly explain how everything is set up. So we know that our AC power, alternating currents, goes from positive to negative, constantly switches between positive and negative. So in the first cycle, that's the positive cycle, the topmost node gives off positive and the bottom node gives us negative. So here, this is our transformer that's stepping down the voltage, and the transformer is connected to an AC power source. Okay, so now when the electricity is flowing, so it goes here, then here, we have four diodes connected together this way. When the electricity gets to this point, it now has to decide which diode is it going to go through. So take note that a diode allows electricity to flow through it when it is connected in forward bias mode. And to tell if a diode is in forward bias mode, the diode points in the direction of a forward facing arrow. So that's like in this case, but here it's not in the form of going, it's not in the facing the direction of a forward facing arrow. So this is in reverse bias mode. So the electricity would go through this diode, then it comes through here. Then so this is the positive, so this is the capacitor. So the positive terminal of the capacitor is connected to the output from our diodes. Then the capacitor is powered up, so the capacitor is charged. So the essence of the capacitor is due to the fact that the alternating current constantly switches, and during that switch there will be a point, there will be intervals where there will be no power. So at those points the capacitor will release off its voltage to continue powering our circuits. So that's the essence of the capacitor. So once there's power, the capacitor charges up. When there's no power, the capacitor gives off its voltage. Okay, that's that part. So capacitor charges up, so the electricity goes this way, then some goes this way through the resistor to step down the current, turns on the LED, then they all come back here. So at this point it's now going to have to decide which of the diodes it's going to go through. And take note that both of these diodes are both connected in forward bias mode. Now to decide which diode it's going to go through, you need to remember that electricity flows from a higher potential to a lower potential. So the voltage started in from here. So let's say here we have 20 volts. Then by the time it passes through the diode, there's going to be a voltage drop. So let's say we have 19.3 volts. Then once it moves through the capacitor and the resistor past the LED, there will also be a voltage drop. So let's assume by the time we reach here, we have 0.7 volts. And here we have 0 volts since it's connected to the negative terminal. Okay, so now here we have 20, here we have 0, and we say electricity goes from the higher potential to the lower potential. This is the lower potential, so the electricity is going to flow in this direction, making use of this diode. Then it comes back into our transformer at the negative terminal. So that's the first half explained. Let me wipe this off, then we'll move through the second half, which is very much similar. Okay, so now in the second half, the topmost is negative, the top terminal is negative, the bottom terminal becomes positive. Okay, so now the electricity flows from positive to negative according to conventional current. So I don't know if I mentioned this earlier, but I'm explaining this using conventional currents. Okay, so we're going from positive to negative. So now the electricity goes this way. Upon reaching here, it now has to decide which diode is it going to go through. So it's looking for the diode in forward bias mode. That's this one. Then it moves through here. Then coming out from here, it's positive. So no matter what, like the output coming out from this diode connection is always going to be positive. As we've seen earlier, it's positive, now it's also positive. Okay, moving forward, the electricity goes through, the charges the capacitor like before, moves through the resistor, powers our LED, then comes back here. But at the point of reaching here, it now has to make a decision. Which diode is it moving through? So here we have 20 volts and here we have 0 volts. Because this is negative 20 volts, so just assuming we have like 20 volts when we start up the circuits. Then since we're going from a higher potential to a lower potential, it makes use of this diode, then comes back into the transformer. So here we are making use of this diode and this diode. That's the negative cycle, and the positive cycle we made use of this diode and this diode. Okay, so that's a brief explanation about how this works. I would add a link to a YouTube video that gives a much more detailed explanation into how this works. So with that said, let's go into the demo. Okay, so this is it. So this is the AC power source. This is the AC power source. Then here we have the transformer. There is a 12 volts transformer. Let me try to zoom in on this. Yeah. Okay, so it steps down to 12 volts. Then here we have our diodes. So this is properly. Okay, so these are the diodes here, 4 diodes. And here we have our capacitor, the LED. Here is the resistor. So it's all connected the way it's been shown in the circuit diagram. So that's the same connection that's used here on the Vero board, and yeah, everything is soldered down. Okay, so this is the terminals of the transformers. So it's constantly switching between positive and negative, positive and negative. Then it moves through, then it goes to the capacitor. That's through this wire here, moves to the capacitor, then capacitor takes it through the resistor to the LED. Then from the LED and the capacitor, the negative terminals from the LED and the capacitor now move back through the diodes, then go back into the transformer. So that is how it works. So yeah, thank you. Peace.